Blockchain technology ensures security and trust through decentralization, cryptography, and consensus mechanisms. These principles eliminate reliance on central authorities, creating a secure digital interaction framework. This video will explore these principles and their real-world applications as of 2026. In traditional systems, data is stored in a centralized database controlled by a single entity. This creates a single point of failure where the entire system can be compromised if that central point is attacked or fails. Blockchain technology eliminates this vulnerability through decentralization. Data is distributed across a network of independent nodes, where each node maintains a complete copy of the ledger. This distributed architecture means there's no single point that can be targeted. Even if some nodes fail or are compromised, the network continues to operate because the data exists in multiple locations. Each node maintains a copy of the entire ledger, ensuring redundancy and data integrity. This makes blockchain resistant to manipulation and censorship, as changes would need to be approved by the majority of the network. By distributing data across many nodes, instead of relying on a single central authority, blockchain creates a more secure and trustworthy system where no single failure can bring down the entire network. Cryptography is fundamental to blockchain security. Public key cryptography, like ECDSA used in Bitcoin, secures transactions with private keys for signing and public keys for verification. This image shows how a message from Alice to Bob is encrypted using Bob's public key and decrypted using his private key, ensuring secure communication. Hash functions, such as SHA-256, create immutable links between blocks, ensuring data integrity. Any alteration would change the entire chain's hash, making tampering easily detectable. This diagram illustrates the SHA-256 algorithm, showing how it processes a message through padding, expansion, and compression to create a unique hash. This image shows blockchain blocks connected by hashes, where each block's header contains the previous block's hash, creating an immutable chain. If block data changes, the hash completely changes, making any tampering immediately detectable throughout the chain. Consensus mechanisms are protocols that validate new blocks and prevent attacks in blockchain networks. They ensure all participants agree on the state of the ledger. Proof of work, used by Bitcoin, requires significant computational effort to validate blocks. This makes it extremely difficult for any single entity to control the majority of the network and attack it. Proof of stake, adopted by Ethereum after its 2.0 upgrade, works differently. Participants stake their cryptocurrency as collateral, and validators are chosen based on their stake. This incentivizes honest behavior since dishonest actions would result in losing the staked funds. Byzantine fault tolerance variants ensure consensus even when some network participants are faulty or malicious. These mechanisms allow the network to reach agreement reliably, maintaining security and trust. Once added, blocks are permanent and visible to all participants. This immutability and transparency foster trust through auditability. Smart contracts on platforms like Ethereum automate trust via code, executing only when conditions are met without intermediaries. This creates a tamper-evident system where trust is mathematically enforced. The Ethereum 2.0 upgrade, completed in 2022, marked a fundamental change in how Ethereum operates. Instead of the energy-intensive proof-of-work mining used before, Ethereum now uses proof of stake, where validators stake cryptocurrency to participate in block creation. This new architecture includes the beacon chain for coordination and shard chains for improved scalability. The transition brought significant improvements. Energy consumption was reduced by over 99% compared to the previous proof-of-work system. Validators are selected based on their stake, and the process includes staking, validating, and receiving rewards for honest participation. These improvements enabled Ethereum to handle more transactions efficiently, facilitating widespread adoption in decentralized finance applications. Quantum computing represents a future threat to blockchain security. Powerful quantum computers could break traditional encryption methods that currently protect blockchain transactions and data. Traditional cryptographic algorithms, such as ECDSA used in Bitcoin and Ethereum, rely on mathematical problems that quantum computers can solve much faster using algorithms like Shor's algorithm. This could compromise private keys and transaction security. To prepare for these threats, quantum-resistant cryptography is being developed. These algorithms are designed to remain secure even against powerful quantum computers, using mathematical approaches that quantum attacks cannot easily break. Projects like Quantum Resistant Ledger implement quantum-resistant algorithms, such as XMSS, which uses hash-based signatures to provide long-term security for blockchain networks against future quantum computing advancements. Different blockchains operate as separate networks, each with their own rules and data. This creates fragmentation in the blockchain ecosystem, where valuable information and assets remain isolated on individual chains. Interoperability protocols solve this problem by enabling cross-chain communication. Protocols like Polkadot and Cosmos create bridges that allow different blockchains to interact and share data securely. Polkadot uses a relay chain that coordinates multiple parachains, allowing them to communicate through shared security and messaging. Cosmos employs a hub-and-spoke model with inter-blockchain communication protocol for seamless cross-chain transfers. This interoperability enhances the overall utility and efficiency of blockchain technology by enabling cross-chain asset transfers, shared resources, and unified ecosystems. High-profile hacks, like the 2025 Ronin network exploit, highlight vulnerabilities in bridges and smart contracts. These incidents have led to improved auditing standards and tools, such as those provided by CertiK and OpenZeppelin, to better secure blockchain applications. Over 70% of Fortune 500 companies are exploring blockchain for supply chain and identity management. This reflects a growing trend of enterprise integration, where blockchain is used to enhance security, transparency, and efficiency in various business processes. Blockchain technology enables secure tracking of products throughout the supply chain, from manufacturing to delivery. This creates immutable records that prevent fraud and ensure product authenticity. For identity management, blockchain provides decentralized identifiers that give individuals control over their personal data. This reduces the risk of identity theft and enables secure verification of credentials without centralized databases. These enterprise applications demonstrate how blockchain enhances business processes through cryptographic security, transparent record keeping, and automated verification systems. Layer 2 scaling solutions address blockchain's scalability challenges by processing transactions off the main chain. This approach allows networks to handle significantly higher transaction volumes without compromising security. These solutions can handle up to 2,000 transactions per second, far exceeding the limitations of many Layer 1 blockchains. Popular implementations include Optimism and Arbitrum, which use optimistic rollups to batch transactions efficiently. This off-chain processing resolves historical bottlenecks while maintaining the security guarantees of the underlying blockchain. AI blockchain integration is accelerating, with projects like Fetch.ai using decentralized AI for secure data marketplaces. This integration enhances data security and privacy by combining AI's computational power with blockchain's immutable ledger. This approach creates decentralized marketplaces where data can be shared securely without intermediaries, reducing risks of data breaches. The AI on blockchain market is projected to reach $45 billion by 2027, driven by these secure and private data solutions. Sustainability remains pivotal in blockchain technology, with proof-of-stake adoption driving the majority of new blockchains. This shift addresses the environmental concerns of traditional proof-of-work systems. Traditional proof-of-work blockchains, like Bitcoin, require massive computational power to validate transactions. This process consumes enormous amounts of electricity, contributing significantly to carbon emissions. Proof-of-stake offers a sustainable alternative. Instead of mining with hardware, validators stake cryptocurrency as collateral to participate in consensus. This approach dramatically reduces energy consumption while maintaining security. The energy reduction is substantial. Proof-of-stake uses less than 1% of the energy compared to proof-of-work systems, making it far more environmentally friendly. This shift has been rapid. In recent years, 85% of new blockchains have adopted proof-of-stake, prioritizing sustainability alongside security and efficiency. Looking ahead, the proof-of-stake model promotes environmentally friendly blockchain solutions, supporting global efforts to reduce the technology sector's carbon footprint. Bitcoin's proof-of-work consensus mechanism creates security through computational competition. Miners solve complex mathematical puzzles to validate and add new blocks to the blockchain, requiring significant computational power. This miner consensus ensures that blocks are only added when the majority agrees, preventing double spending and attacks by making it economically unfeasible to control the network. The blockchain diagram illustrates how each block contains data and is linked to the previous block through cryptographic hashes, forming an unbreakable chain. As of 2026, over 700,000 blocks have been added securely to Bitcoin's blockchain through this process. Bitcoin's resilience was tested in 2013 when the Mt. Gox exchange suffered a major security breach, losing approximately 850,000 Bitcoins. This was not a vulnerability in the blockchain itself, but in the centralized exchange platform. Despite this massive loss, Bitcoin's network recovered and continued operating securely. The blockchain's decentralized design meant the stolen funds couldn't be reversed without consensus from the entire network. This incident demonstrated the immutability of the blockchain. Once transactions are recorded and confirmed, they cannot be altered or undone, providing strong security guarantees. Smart contracts on Ethereum are self-executing programs that run on the blockchain. They automatically enforce agreements when predefined conditions are met, eliminating the need for intermediaries and creating trust through code. In decentralized finance platforms like Uniswap, smart contracts automate escrow services. They hold funds securely until trade conditions are fulfilled, allowing buyers and sellers to exchange tokens directly without needing a middleman. A 2024 case study on compound finance illustrates this power. During a severe market crash, the platform's smart contracts automatically liquidated positions that became under-collateralized. This code-enforced mechanism prevented potential defaults totaling $1 billion, demonstrating how blockchain automates trust. Through smart contracts, Ethereum enables code-enforced trust, reducing fraud and enhancing security in decentralized applications. VeChain is a blockchain platform specifically designed for supply chain management and product traceability. Using blockchain technology, VeChain records every step of a product's journey from farm to consumer, creating an immutable digital record that cannot be altered or falsified. A real-world example occurred in 2025 when VeChain's system prevented a major contaminated product recall by providing verifiable proof of product safety through blockchain data. The implementation resulted in a 40% reduction in fraud among VeChain's partnered logistics firms, demonstrating the platform's effectiveness in supply chain management. This case showcases blockchain's powerful utility in modern supply chain management, where trust and transparency are essential. Central bank digital currencies, or CBDCs, are digital forms of fiat money issued by governments using blockchain technology for enhanced security and efficiency. A prime example is the Bahamas Sand Dollar, launched in 2020 as the first CBDC in the Caribbean and expanded in 2025. It leverages blockchain for instant,